Hello everyone, welcome to 4.2, our lesson where we're adding, subtracting, and multiplying polynomials. We're also going to be learning how to cube a binomial in this lesson, as well as using Pascal's triangle, we'll learn about that later, to expand binomials. But first, let's do a little quick joke of the day. Why is a computer so smart? Go ahead and pause the video if you want to spend a little more time thinking about that. But why is a computer so smart? Well, it listens to its motherboard. So a quick little joke to start us off. Let's get into now adding and subtracting these polynomials. There's two different ways we can do this with a vertical format or a horizontal format. So a vertical format would be kind of more of in a column form where we just put one polynomial on top of the other one, and then just combine like terms going down. It's kind of what they're doing there. Or the horizontal format where you just put them next to each other and you just start kind of visually just seeing you're going to kind of combine like terms here on these polynomials. So that's what we're doing on this. We can see we do the same thing for subtraction. We can do it for vertical format or horizontal format. The difference there with subtraction, though, is that we're going to be pretty much changing the second one to their opposites. So you keep the first polynomial the same, but you change the second one to its opposite. So you're pretty much just distributing a negative into that second polynomial to change all of its signs. That's what they're showing you here, changing all the signs. And then you go ahead and just combine like terms. So when you're adding or subtracting polynomials, eventually you do just combine like terms. Adding, you just combine like terms the way they are, but subtracting, you have to change the second one, the one that comes second, by subtracting it, by distributing the negative in there, changing all the signs, and then combining like terms. It's that easy. Okay, if you can go to your notes on page 85, we're going to see the extra practice 1 through 3. It says find the sum or difference. So sum here would be where you're going to add them. You're basically combining like terms and you're adding them. So when you see the word sum, let's go ahead and write this right above here for sum. When you see the word sum, that basically just means you're going to combine like terms on that. That's meaning you're adding. And when you see the word difference, that means subtracting. And we're just going to, in that one, we're going to distribute the negative first, which would be that sign in the middle. So distribute negative, then combine like terms. Okay, so for number 1, it's got an addition here, so we're just going to be doing sum, we're just combining like terms. And we can do it horizontally or vertically. I'm going to kind of do this one horizontally, just looking at the x squareds first. So negative 4x squared and a negative 1x squared, that's just going to give me a negative 5x squared. So I can just kind of do that mentally in my head. And then the x terms, negative 6x, positive 7x. So we had to take 6 away from 7, so it's going to give us a positive 1x there. And then 18 and the 8, they're both positive, so they'll add together. And that's going to give us a positive 26 then at the end for that. So there's our answer for adding these two polynomials together. Number 2, it has a subtraction sign, so we're going to be first distributing the negative and then combining like terms. So if I distribute this negative into here, that's going to change all this. You might want to even just start by changing this to a positive and then change all these to their opposites. That makes that a positive x squared. This is going to make this a negative 24x. Let's make it a positive 63 there. At that point, you can then just combine like terms the way you see them. That would be fine. So you got, again, we do what we did just on number 1. For the x squared, 6 and positive 1. So 6 plus 1 would give us 7 for the x squareds. The x terms, I have a negative 12 and negative 24. That's going to make a bigger negative, negative 36x when I add 12 and 24. Positive 48 and a positive 63. When we add those together, you can do that off on the side, 48 plus 63, but that's going to give us 111. So 111 for that one. Number 3, the sign in the middle. You always got to look at that sign in the middle. it's negative, so we're going to subtract. We're going to change all of these signs here. So again, I can do it this way, change that to a plus, make this one now positive. This will become a negative 5x squared. This will become positive 7x. This will become negative 13. And this time I'm going to do it with columns. I'll show you the column one. So I would take this right here. I could put it over here. Positive 11x to the fourth will go under that one. I have an x squared one, so negative 5x squared goes in the other x squared term here, right there. 7x, you can put it over here, plus 7x, and then minus 13. So that way you can see the column form. I don't always do this, but just if you prefer this method, you can do it this way. That way you can definitely see these two are opposites. They're going to cancel each other out. We're not going to have any x to the fourths. But we do have this one. It's not going to combine with anything. So we start off with a negative x to the third for the answer. These x squareds combine, giving us negative 8 for the x squared. And then this gives us a positive 17 for the x, and then negative 15 for that constant term there. So that's our answer then from subtracting these two polynomials together. Gives us this 4-term polynomial here. Okay, so now we're going to look at multiplying these two polynomials together. And again, we can do it in either a vertical format or horizontal format. So, vertical format would be, again, like in columns here, one on top, one on the bottom, kind of like the way you used to do multiplying, 3-digit number times a 2-digit number, that kind of thing. And you would just take the, start multiplying here. You maybe multiply by negative 3 first, so negative 3 times the 4, then times the 2x, then times this one gives you those 3. And then x times those 3 up there would give you another 3, and then you just combine like terms then for your answer. Okay, that's just doing in a vertical format. Horizontal format is kind of more doing a double distributive property. So you're going to distribute, or even a triple distributive property in that case as well. They're kind of taking this blue one over here, has 3 terms, multiplying it by these two here. So that the 3y squared times those two, then times those two, and so on. And then they're just getting it out to, they've got it all multiplied out, and then they're going to just combine like terms. So here's another one. We have 3 polynomials together. You have 3 of them. Well, you just got to do 2 at a time. If you have 3 of them, you multiply binomial times binomial to give you a trinomial here, and then you multiply the trinomial times the binomial to give you your final answer eventually. Once you do that, you get your final answer, one big long polynomial answer there on that one. Now I'm showing you down below here another way that you can multiply, which is the box technique. So if I did these 2 binomials here, instead of using maybe FOIL, I could put it into a 4 square kind of situation, put x minus 1 up on top, x plus 4 on the bottom, or on the side I should say, and then go ahead and just fill in your boxes. So x times x fills in this with x squared, x times negative 1 is a negative x, and so on. You get the 4 boxes there, as you can see, combine like terms to give you your trinomial. And now you have a trinomial times the binomial. You can make another big box here with a 3 by 2. So 3 goes across the top, 2 on the side, and you can do the same thing to get your 6 terms, and if you have any like terms, you'd want to combine those like terms. In this case, there is no like terms, so all those 6 terms, just like right here, is your answer. Okay, so back to page 85, you should still be there. So number 4, it's a monomial, just a single term, times the kind of 4-term polynomial there, which will be a cubic polynomial. On this, all we're doing is just a distributive property. We're just going to distribute this, 2x into here. That's all we're doing. When it says find the product, that means to multiply. So you want to make sure you realize that does mean to multiply. So we're just multiplying with the distributive property on all of this. So first of all, 2x squared times this 2x to the third. So 2 times 2 is 4. And then you got to add the exponents. So it's going to be x to the 5th power. You always add exponents when you're going to multiply in like this. When you're multiplying at some x term times another x term, you add the exponents. And then the next one, 2 times negative 1 will give us a negative 2 for the coefficient, but then you add the exponents, 2 plus 2 will give you a 4 for the exponent. And 2 times 3 for the coefficient is going to give you a positive 6. You're going to have a 2 plus a 1 for the exponent, so x to the 3rd power. Notice how it's dropping down, 5, 4, 3. The next one will probably be 2. And that's going to be 2 times negative 5, so negative 10. And this is just going to be an x squared. There's no x's on this one, so it's just that x squared, like I said, probably going to be 2 when you dropped it down. There's our answer for multiplying the monomial times that polynomial there. Now this one's got a trinomial times another trinomial. This is going to be a bit of a long one. We can do this, kind of in a or triple distributive property, I should say. For this one, I'm starting with x to the fourth. I'm going to multiply x to the fourth times all three of those. So x to the fourth times the first one. So that's basically coefficients 1 here. 1 times 3 would be 3. And then you're going to have the exponents, so it's going to be x to the 4 plus 2, which will give us 6. And then, again, 1 times the next one, negative 6. 1 times negative 6 is negative 6. The x's, though, is going to be 4 plus 1, so that's going to be 5 on that one. And it's x to the fourth times 1. So 1 times negative 1 is negative 1. It's just going to be negative 1x to the fourth. Okay, now you go to the next term, negative 10x squared times all three of those again. Like I said, it's going to be a bit of a long one. So negative 10 times 3 is negative 30. But where do we put that? We got to figure out which one do we have. We're going to have an x to the fourth term, because 2 plus 2 will be 4. It's going to go right under here. So we're going to say negative 30 x to the fourth. Okay, then our next term, negative 10 times 6. So that's going to be a negative, or a positive, sorry, negative times negative, positive 60. And this is going to be an x to the third power. And then negative 10 times negative 1 is positive 10. And that's going to be just an x squared for that one. And now for our last one, 25 is now going to multiply these three. So 25 times the first one is 75x squared. That's got to go under the other x squared one here. So 75x squared. And then 25 times negative 6, that's a negative 150. And that's going to be just an x on that one. And then 25 times negative 1 is negative 25 there at the end. Alright, so now we're just going to combine all these like terms together. So kind of one big long line here. Any like terms. So we have some that are on top of each other. Only actually these two are the only like terms that we have. The x to the fourth, the x squared, those will combine, but everything else is just going to be coming in our answer. So starting with the x to the sixth term, we always write it in descending order, which is standard form. And then minus the 6x to the fifth. These two combine to give me negative 31. So I'm getting negative 31x to the fourth. Then I got my 60 x to the third. My x squareds combined, that gives me positive 85 x squared. Then my negative 150x, and then my minus 25. That is our answer there. So all you need to make sure you do, there's two kind of steps here. You multiply, then combine like terms. So multiply, and I'll put then combine like terms. So on this one we just had to multiply, but here we have to multiply then combine like terms to get our final answer. So here we have the three polynomials. Let's just start with the first two. We'll just do these first two here. So a little FOIL, or if you wanted to use that box, you can use the box and write the box on the side. But x times x would be x squared. X times 2, so I'm going to be kind of distributing, so I did x times x, then x times 2. So that's going to be just a negative 2x. And then we're going to see inside, we're going to have our inside ones here. 1 times x is going to be positive 1x. And then our last ones there, 1 times negative 2 is negative 2. So when I kind of combine these two like terms here in the middle, I'm going to get an x squared minus 1x minus 2. They'll combine to give you a negative 1x. So let's put that back into a parenthesis. And now we're going to bring down this next one here. So we're going to see x plus 6 in this parenthesis. So now again I have a double distributive property. So again I just did the same thing. I multiplied, then I combined like terms with these two. Got to multiply again. I usually like multiplying with the binomial here into the trinomial. Whichever one's smaller, I like to do that. So x times these three, then 6 times those three. So I'd see x times x squared. Let's start with that. So it's going to be an x to the third power. And then x times negative x, that's going to be negative x squared. And then x times negative 2 is negative 2x. And then multiply 6 in here. So 6 times x squared, that's going to be 6x squared. I'm going to put that in a column form just right underneath here. So 6x squared goes there. 6 times negative x will be negative 6x. And 6 times negative 2 will be negative 12 at the end. And now we combine. So nothing to combine for x to the third, so x to the third is how we start the answer off. Then we're going to subtract here, and 1 minus 6, or I should say, take 1 away from 6, it's going to be positive 5. So plus 5x squared. These both are negative. It's going to make a bigger negative, so we add those numbers and get negative 8x. And then we get minus 12 here in the end. As you're combining, you do not add exponents. That's one mistake I've seen in the past. You're going to just combine them the way they are. So how many x squared do you have? How many x's do you have? That kind of thing. So this is our final answer after we've multiplied and combined them, the like terms together. Number 7, I'm going to start with these two just so you can see that we could start either way. It doesn't matter. Let's go back to a different color. So if I start with these two and do FOIL, so I do 6 times 4, I can get a 24 there. 6 times negative 5, that's going to be negative 30x. Inside here, that's going to give me a negative 4x. And then my last one's here, that's going to be positive. Negative times negative is positive. And then we're going to see it's going to be 5x to the second power there. Again, I can combine those two x terms in the middle, leaving me with 24, negative 34x, and then my plus 5x squared. Let's put that back in a parenthesis, and let's bring our next one down. So we're going to say it's 2x minus 3 to multiply this trinomial by. So again, starting with the binomial, 2x, I'm going to go into this trinomial, multiply 2x times each of these in the trinomial. So 2x times 24, that's going to give me 48x. Then 2x times negative 34, that's going to be a negative. 2 times 34, that's what, 68. So 68. It's going to be an x squared because I have x times x. So x squared on that one. And then 2x, so 2 times 5 is 10, so we'll put 10 down here. And x times x squared will be an x to the third. And now we do the same thing with negative 3. Negative 3 is going to go into here. So negative 3 times, 24. Well, that's going to be a positive number. In fact, I think I might just go the other way. I might start to the end and bring it back this way. X squared and so on. And we do want to write our answer in descending order. So you can see right now the way it is, it's not going to be in descending order at the moment. We'll eventually need to write it in descending order. So let's just start off here. Negative 3 times 24, that's going to be negative 72. So let's put the negative 72 kind of up in front here. So negative 72, it's not combining with anything. Negative 3 times negative 34. Maybe we'll just go quickly to a calculator for that. So 3 times 34. Any big numbers, you can always use your calculator. 102 is our number there. So that's going to be a positive 102. So plus 102x. That's going to be going to this x term here. 102x. So the x's are lined up. And then negative 3 times 5, it's negative 15. It will have an x squared, so we'll line it up with this other x squared term. 15x squared. And now we combine them together. So I'm going to write it in descending order. So I'm going to kind of go backwards a little bit because my x to the third is here at the end. So it's got to start off with 10x to the third. So my answer is going to be 10x to the third. And then the x squareds, they'll combine, be adding those numbers together, be a negative. This is going to be, what, 83. So 83 x squared. And then these two combine, give me a positive x term here. That's going to be 150, 48 plus 102. So 150x, and then the negative 72 will be in the back there at the end. So that's our answer here from these three multiplying together. So this one I multiplied these two together. I might have wanted to multiply those two together first. It really doesn't matter, however you want to do that. If you go back to page 83, you're going to see our core concept here has some special product patterns. We've seen some of these before, so this would be our difference of squares. Sum and difference could become a difference of squares, which is what we have here. And these are always going back and forth, so if we need to factor the difference of squares, it goes back to x plus 3, x minus 3. We've done that in the past. But if we need to multiply these two, if it's got a sum and a difference, x plus 3, x minus 3, we can just multiply the x's and multiply the 3's. Because if you do the outside and inside, you'll cancel those out because you can see it's not there. You just have two terms. Another one we see here is the square of a binomial. We saw these when we did the completing the square. So that's what we got here. Y plus 4 squared. that can become a perfect square trinomial. And here's what we used to do. We took this perfect square trinomial and put it into our binomial squared. These can go back and forth, like I've said. So here's another one. We have 2t minus 5 squared. It's like you have two of these exactly the same, and you could FOIL it and then eventually get to this, which gives you a perfect square trinomial. And again, this would be coming back into, you can go back and forth between these two. But now we have a new one here called a cube of a binomial. So if you have a binomial that's cubed, so now it's not just a binomial squared, it's a binomial cubed. Okay, so now it would have more of a longer pattern. We're going to get 4 terms out of this, and we'll see how to do these here in a little bit. It might look a little daunting at the moment. You're seeing it, you got to have 4 terms here, and how do you get these 4 terms? Don't worry about right now how to get those. We'll see how to do that in just a minute as we start to work them out. But just keep remembering that you can reference back to this, core concept to help us. So here's a couple here. Here's a sum and a difference. We would just multiply the first ones, multiply the last ones, and we would get our answer. So you're just doing 4n to the times itself, 5 times itself, giving us just 2 terms for a difference of 2 squares. Here's another one. We can do the same thing. Well, actually not the same thing, but it's a binomial squared, so we know it's going to become a perfect square trinomial. We can think of this as actually 2 of them. So when we do this, there's 2 of them, but we can do it easier, I guess, maybe, or a shortcut maybe. Might think about multiplying this times itself, so 9y times itself would give you your first term. The multiplying this one times itself, the 2 times itself would give you your last term. And then multiplying these 2 times each other and then times 2 right here in the middle would give you your middle term. There's another way you can do that, or you can just separate this into 2 binomials and use FOIL, and you can get the same thing, just a trinomial there when you multiply that all out. Now here's that cube of a binomial. So here's, the cube of a binomial is doing it in a different pattern. They can do it in this longer pattern here, but it does a little bit daunting. And you can see this in the book where they're showing you the pattern here, just like they showed you on that core concept. I don't usually do this. So this is not usually maybe the typical way I would probably do it, just because it takes remembering all of this to do that. For me, I would probably separate this out into 3 exact binomials and then multiply them all out. So that's kind of how I'll be doing this here in a second. Okay, so back to page 85. So number 8, that gives us a sum and a difference. They're almost exactly the same, just one's a difference, one's a sum. So that means that we can just multiply the first ones here. You can multiply your first ones and then multiply your last ones. You don't need to remember to multiply the outside and the inside, just because you'll cancel those out. So we have 3y times 3y. So those two will multiply each other. It's just the same thing as saying 3y squared. And then you're going to have negative, 8 times 8, so it's going to be like a minus here in the middle, because negative times positive will be minus. You're going to have an 8 times itself, so like an 8 squared. So 3y, so parenthesis there, 3y times 3y, that's going to give us a 9y squared. And then 8 times 8 will be 64, so minus 64. So there's our answer right there from the sum and the difference. It gives us a difference of 2 squares. Now here's the one with the cube here. So binomial cubed. There's 3 of these exactly the same. So we can kind of think of it as this. It's like saying 2v minus 1 times another 2v minus 1 times a third 2v minus 1. For me, this just seems easier to do it. It's not that much more difficult than the other way. The other way means you have to remember a lot to do that. So I think this will be a little bit easier because we remember how to do FOIL. Just take 2 at a time. So we just do these first 2, just like we did before. So that's going to give us a 4v squared. Outside is going to give us negative 2v. Inside's also negative 2v. And then the last one will be a positive 1. And so we combine those 2 in the middle. It's going to give you a 4v squared. And then minus 4v, and then plus 1. We can put that into a parenthesis and then bring down this other one here, just like we saw before, 2v minus 1. Multiply 2v into the whole thing. So we can start with 2v times this one, so 2 times 4, that's going to give us 8v to the third power. This is squared here. And then 2 times negative 4 is negative 8v to the second power from v times v. Then 2 times 1 is just going to give us 2v here at the end of that one. Then negative 1 times all of these, we'll just change those signs. This will become negative 4v squared. I'll put that underneath my other v squared one. This will become positive 4v, so put it under the other v1. This becomes negative 1, so minus 1 there. Combine like terms, so our 8v to the third, and then it has our negative 12 v squared, and then our positive, this is going to be 6v here, and then minus 1 at the end. So there's our final answer for multiplying this binomial to the third power. We get this 4-term polynomial. So like I said, it's not that hard. If you just remember there's 3 of them, and you just take 2 at a time, multiply 2 at a time, combine like terms, and you get your answer. Okay, if you go back to page 81, that first page on the notes, it has a few here for you to try, so I'm going to have you try these. It's just the same thing we just did, x plus 1 to the third power. It kind of gets it started here. Here you're just going to write out the other 2 binomials. You say, okay, these are 2 more, so you just put 2 more binomials right there, and just start multiplying 2 at a time to get them. You get a trinomial times a binomial, and then your 4 terms will go in here. So pause the video for a second and work on that on letter A. Just do letter A. So go ahead and pause the video. Okay, so that's what you should have got from letter A right there. There's your 4 terms eventually at the end. So I'm multiplying, these 2 here with this. X times this one is the top one, and then 1 times that one is the bottom one, and combining like terms to give me there. Alright, you don't have to do B. Go on to do the next. Okay, so I'll give you a moment to try C and D. So try both C and D. C is just with a negative 1 inside there, so it'll be very similar, but then D is with an A and a B in here, so that'll be a little bit different maybe with the letters. Go ahead and try that. So go ahead and pause the video again, and then when you're finished, go ahead and start it again to see the answers. Okay, so here's what you should have for C and D then from what you just did. So you have the 3 again here, multiply 2 at a time, getting into a trinomial times a binomial, and then back down into a trinomial again. Again, you have all 3 of them out here, multiply 2, and you get the trinomial, and then binomial times trinomial gives you again 4 terms for that answer there. Okay, so this is what we could do if it's a binomial to the third power, but what if we had a binomial to the 4th power, like we had x minus 1 to the 4th power, or if it was to the 5th power, x minus 1 to the 5th power, or as it gets bigger and bigger to the 6th power, to the 7th power, and so on. Well, that would take some other maybe way to do it, because we're not going to want to keep multiplying and multiplying forever on this. That would take quite a long time. So they do have a bit of a shorter way to do that, and it's called the binomial theorem. So this binomial theorem is can work for any of these polynomials, any binomial to any power it could work for, but usually we use it for, like when it gets to especially maybe starting with the 3rd power, we could use it for that one, or especially for the 4th power, 5th power, and so on. So like when it gets to like 8, to the 5th power, to the 6th power, and we got this big long, polynomial out here. So how do we do this? How would we go about using this binomial theorem? So there's a couple things going on here. So the first thing is there's an A person, there's an A guy. So between A and B here, there's an A guy. Your A is your first term, your B is your second term. So something's happened with A, and you can see what's going on with A is that the exponent starts at 6 and then it drops down 1 every time until it gets to 0. A to the 0 power means there's no more A. On that last term, you can see right there, there is no more A in that term. But the second thing, the second part of this, with the B, what's happening with this B guy, he's doing the opposite. And so you can see he's not in the first term. There's no B in the first term because he's B to the 0 power in the first term. And then he goes to B to the first, B to the second, until he's finally B to the 6th power by the very end, the same exponent that we have on the outside of the binomial. So that's what's going on with those first terms there, those terms. But then the last thing would be, actually a couple more things, not just the last thing, but one thing we might want to recognize is that the exponents on these will all add up to your power on the outside there. So the exponent here is 6, which is 6. 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. They all add up to 6. So that's something also that's true about that. But then, what about those numbers in front? The coefficients. These numbers in front. So this would be a 1, this is a 6, this is 15, 20, and so on. What about those? Well, we get those from a particular triangle called Pascal's triangle. I mentioned that at the very beginning. So Pascal's triangle, that's this thing right here on page 84. So look at 84 where Pascal's triangle is. And you can write on the top up here, this is for binomial theorem. So you may want to put that down. This is for binomial theorem we use this for. And you could say they're calling it binomial expansion. They can call it either binomial theorem or binomial expansion, either way, but typically it's most probably commonly referred to as binomial theorem, but sometimes they do say expansion. This is the Pascal triangle over here. So you could start the triangle just with these 3 1s right here, a little triangle of 1. That's why I circled that. You can go ahead and circle that right there on your paper. You start with those 1s and you can generate this triangle on your own. All you have to do is just add these. So you're adding 1 plus 1, getting the number below it for 2, and then you start and stop the row with 1s. And then you get 1 and 2 make 3, 2 and 1 make 3, and then you begin and end each row with a 1. And same thing with getting 4 here. This is 6 here, another 4, begin and end each row, and so on. I wrote down the next row here, so go ahead and you can write the next row on your paper. So this right here will be from 5, let me use a different color there. So this would be from 5 and 1 right there, getting you 6. 5 and 10 gives you 15. 10 and 10 gives you that 20. And then the 10 and the 5 gives you another 15 there. 5 and 1 gives you another 6 here. And you start and stop the row, begin and end the row with 1s. You can go ahead and get the next row as well. So go ahead and try to get the next row. Spend a moment to try to get the next row. You can pause the video for a second and get the next row and write that out down below here. So you're doing 6 plus 1, 6 plus 15, and so on. Okay, so there are 3 parts to each term that we multiply. So we already talked about the A term, the B term. Those we're going to have to multiply those. We also have to multiply by a Pascal number. So the Pascal number is these numbers here. So we got to figure out which row of numbers do we need to have for each term. So if we have something like to the 4th power, for instance, right here, we're going to use this row with 5 numbers in it. It's always going to be 1 more number than your exponent number. So your number of terms will always be 1 more than your exponent number. That's something to keep in mind. So if we have, to the 5th power, you're going to have 6 numbers. You're going to use those 6 numbers then for each of the terms. Your first term, second term, you multiply by those numbers there. So let's see how we kind of work this out. So if we wanted to expand this one here, we could do that. Just go ahead and watch this. We could first need to know what the Pascal numbers are going to be. That's these 5 numbers from the triangle 1, 4, 6, 4, 1. And so for each one, we're going to do this. So we have our Pascal number 1. Our x term is going to be x to the 4th, and our b term is 2 to the 0. That's why it's not there at all. And then our Pascal number for the next one will be 4. Then it's going to be x to the 3rd. That's going to drop down 1. And then it's going to be 2 to the 1st. That's going to go up 1. So you can see you have your Pascal number. Your x term is going to go down by 1 each time. Your 2 is going to go up 1 by each time. Pascal number again. X goes down, 2 goes up 1. Until you get to your last one with x, Pascal's 1. There is no x term because that would be x to the 0. That's why it's not there. And then you have 2 to the 4th. And the last thing to do is just to clean this up because it's a little bit of a mess right now. So you got to clean it up and make it look a little nicer, a little more presentable. So you got x to the 4th here from this one. Here you're going to be seeing this is going to be 2 times 4. So 2 to the 1st and then times 4 gives you the 8. For x to the 3rd, this is going to be a 4 first. To do the exponent first, just like order of operations. So that's going to give you 4 times 6, giving you 24. This will be 8 from 2 to the 3rd power, 2 times 2 times 2. 8 times 4, giving you that 32 there. And then 2 to the 4th is just that 16. You can see another one here if we had this one where it's got 2x and a negative 3. So a term is 2x. Your b term is negative 3. We would need the Pascal numbers of these 6 numbers. And then you just go ahead and do the same thing as before. You can kind of pause the video if you want to look at this a little faster, a little slower, and see what I did. But basically, you can see how we have a lot more numbers going on here eventually when we clean it up. So like this first term is not too bad. We have to do 2 to the 5th power, giving us that 32, x to the 5th. But then over here we have a 5. We're going to have a 2 to the 4th, which is 16. We're going to have a negative 3 to the 1st, which is negative 3. So there's 3 numbers here to multiply together to give you this negative 240. Another thing to keep in mind is the sign in the middle. So if the sign in the middle, let's go back at this last one here with the plus. When the sign in the middle was plus, everything is positive. So every term will be positive. But when the sign in the middle is negative like this one, you'll notice that every term is not negative. They're alternating. So you start positive and then it'll go negative, positive, negative, positive, negative. It will just keep alternating back and forth between positive and negative. It'll always start positive though. So that's something to keep in mind. It'll always start positive. Alright, so let's go ahead and try the ones on our paper back on page 85. Back on page 85. Okay, so looking at page 85, 10 and 11, this one's got an x to the 4th power here. So we need to know, first of all, what those Pascal numbers are going to be. So if you look at your Pascal triangle, when it's to the 4th power, you're going to use these 4 numbers. I'll just put them up here. It's 1, 4, 6, 4, and 1. So those 5 numbers, I should say. It's always going to be 1 more than the exponent number you have. Okay, so here we go with doing this. We need our Pascal number, just like I saw before, right? We have our Pascal number. That's what you wrote down back on the other page, which you should have written down, by the way. So if we went back to this page here, make sure you do write this down here. Pascal number, your A term to the n power, your B term starts at the 0 power, and at that point, then your A term is gonna go down 1 each time. Actually, write that down on this paper. I forgot to say that. So this means your A term, this one goes down 1 each time. And then this one starts at 0, but then this one goes up in 1 each time. So make sure you write that down there on this page where it's on page 84 where it's got the Pascal triangle. So we need our Pascal number, our A term, and our B term for each of these terms. Okay, so here on number 10, our Pascal number is going to be 1. So we need a 1. Let me use a different color here. So we're going to say 1 for Pascal number. And then we're going to have our 4t. So I'm going to put 4t to the 4th power. And then this will be to the 0 power, so I don't need to even write that. Okay? And then we're going to say, okay, plus the next one. I'm just going to always put plus right now until I clean it up, even though I know these signs are going to alternate because this is a negative here. So my next Pascal number is 4. So 4, and then your A term is 4t. This time it's now going to go down 1 to 3. And now we have our B term, which is negative 2. That's going to go up 1 from 0 to 1 now. And then I'll put plus again. Next Pascal number is 6, and then I'm going to have our 4t, and this one's now going to go down 1, so it's squared, and our negative 2 is going up 1, so it's also squared. Again, 2 plus 2 should be 4 there. 3 plus 1 should be 4. And let me bring this down a little bit right down here. So next one, put down here. Our Pascal number is 4, and we have our 4t, and it's going to go down 1 to 1. And your negative 2 is going up 1 to 3. So again, 1 plus 3 is giving me that 4. Plus the last term here. So Pascal number 1, 4t. Actually, I don't need a 4t really. I just need my negative 2. So I don't need 4t on this one because 4t will be to the 0 power. And so you're not even going to need to write that. So it's just going to be the negative 2 to the 4th power. So that's it all out here. Now we just got to clean it up. So if I clean this up now, my first term, I'm going to see 4 to the 4th power. So if you're not sure about that, then just go to use your calculator and you can just say 4 times 4, that's 16, times 4 again, that's 64, times one more 4, that's a 256. I'll keep that to the side there for now. So this is going to be 256 times 1, so it is 256. And it's t to the 4th power. There's our first term. The next term is going to be 4 from the Pascal number, so we're going to have a 4 here to multiply. We're going to multiply it 4 times 3, which we just saw, that was 64. So 64 there, and then negative 2 times 1 is negative 2. So this is going to be a negative number here, so that's why we are going to alternate our signs, positive and negative. So now I can just say, well, 4 times 64 was 256, but now I got to multiply that by 2. So just say times 2 over here, and it's going to be negative 512. So this is going to be a 512, and we're going to still have our t to the third power. So it's still going to have that t in there. Next one should be positive. I can even just put the positive down, and the sign will alternate. So I'm going to have my 6 from the Pascal number, 4 squared is 16 from that a term. This is going to become a positive 4, negative 2 squared. So I multiply all that out. Let's clear this here. So I know 6 times 4 is 24, so I'll say 24 times 16. And that will give me my number. So that's going to be 384, so it's going to be 384, and it's going to be t squared. Next term I know is going to be negative. I can just put the negative down right now. So it's going to be 4 from the Pascal number times 4 to the first, so that's a 4 there as well. And this is going to be negative 8, so times negative 8. So 4 times 4 is 16, so we can just say over here 16 times negative 8, or just times 8. 16 times 8, that's going to give us 128. So negative 128, and this will be just t to the first, or just t. And the last one will be a positive here. We have 4 negatives, so it's going to be a positive. It's going to alternate signs. So it's basically 2 to the 4th power is, this one was 8, so now I multiply that by 2, that's going to be 16. So 16 is how we end this one. And that is our answer right there. This whole polynomial right here, these 5 terms, is our answer. Okay, so number 11, so we come over to number 11. We need the Pascal numbers again. So my Pascal numbers, when it's 5, is the numbers, it's got to have 6 numbers. It's going to be 1, 5. I'm just looking at my triangle back on page 84. So 1, 5, 10, 10, 5, and 1. So we need to first start off with the Pascal number 1. I'll do it this way, green first. So 1 here from Pascal number, and then G, so that's going to be my G is now going to be to the 5th power to start with. 6 will be to the 0, so I don't even need to write that one. I'll put my plus next. Next Pascal number is 5, and then my G now is going to be going down 1 to the 4th power, and my 6 goes up 1 to the 1st. And then the next Pascal number is 10. G is going down 1 again to the 3rd power, and the 6 goes up 1 to the 2nd power. And then the next Pascal number is again 10, so another 10. So maybe I'll put the 10 down here. So 10, and then G goes down 1, so that's to the 2nd power. 6 goes up to the 3rd power. And plus 5 for the Pascal number. The G term here is going to go down to 1, and the 6th term here is now going to go up to 4. Remember, I always check it by 1 plus 4 should be 5. These all exponents should add to 5. 2 plus 3 is 5 here. And our last term is going to be 1. Your G term is not there. You're just going to have your 6 going up to 5. So now we just got to clean it up. This one shouldn't take too long to clean up. So starting here, it's just going to be G to the 5th with just 1 times 1, really. So it just starts off G to the 5th power. And this one's going to be a 5 from Pascal. This is always a 1 here, so you don't need to worry about this. This doesn't have a number. 6 here, so it's just 5 times 6, which is 30. So it's going to be positive 30. And it's G to the 4th. And for this one, it's going to be a 10 from the Pascal. 6 squared is 36. So that's going to be 10 times 36 is 360, so plus 360, and it's going to be now G to the 3rd. Down here I got another 10. 6 to the 3rd power, I might want to try that one over here. Just 6 times 3 sixes. That gives me 216. So that's going to be 216 times 10 right there, which is going to be plus 2,160 for g squared. And then this one's going to be a 5 times 6 to the 4th, so I just times another 6. So let's see, times 6. That's going to now be 1296. So 5 times a 1296 right there on that one. So just put times 5 to get that number. So that gives you 6480. So it's going to be plus 6480, and this one's just g. And then our last one is going to be 6 to the 5th power. So 6 to the 5th power, let's see, 216. 6 to the 4th power was 1296. So 1296, I'll put that there. And then just times another 6. That's going to now give us 7,000. So this is now going to be plus 7,776 with no g's there at the end. So that is our answer then for that binomial theorem problem. Okay, so that concludes this lesson on 4.2. We're adding, subtracting. We're using the Pascal triangle to do the binomial expansion here at the very end. All right, so I'll see you on the next lesson.